Please welcome, from MIT Press, Nick Lindsay and Noah Springer.
All right, ready? All right, so hello everyone. I'm Nick Lindsay. I'm the Journalism and Open Access Director for the MIT Press, and my colleague Noah and I are going to say a few very brief words about why the press is involved in this collaboration with Antikythera. My boss, Amy Brand, who's the director and publisher of the press, very much wanted to be here, but unfortunately a prior commitment out west is keeping her away. We have had a very long-standing connection with this building and with the Media Lab that goes all the way back to the beginning of both organizations in the person of Muriel Cooper, who was the press's first design director as well as a founding member of the Media Lab. Muriel's influence is both broad and deep on the press and the lab, and if you've seen, actually I'm sure you've seen the MIT Press colophon because it's been on the screen numerous times today. That spirit of playfulness and innovation that she brought to her work is clearly evident, and we strive every day at the press to live up to Muriel's example. There are many touch points between the press and the Media Lab over the years, including the Journal of Design and Science, otherwise known as JODS, which was launched in February 2018 and continued on until July 2020. JODS aimed to bridge the gap between design and science, fostering interdisciplinary dialogue and challenging traditional academic silos. The journal is hosted on an open access, open peer-reviewed platform called PubPub from the Knowledge Futures Group, an organization that actually grew out of both the Media Lab and the press, and is now a separate, thriving 501c3. And they offered services and tools to encourage community participation and rich multimedia content, which is something that we hadn't been able to do up until that time. So that combination of the press and the Media Lab really caused us, or gave us this opportunity to be able to do something different. In 2016, the press had the privilege of publishing Benjamin Bratton's seminal work, The Stack, on Software and Sovereignty. This groundbreaking book challenges us to rethink how we view various genres of computation, has really become a pillar of MIT Press's backlist, having sold many thousands of copies. The Stack is the kind of book that the press has been and continues to be known for. As Bruce Sterling aptly described it, Benjamin Bratton's The Stack is a strange, marvelous text of great conceptual beauty. The Stack itself may or may not exist, but it's left everything that came before it in a state of rubble. That's the kind of destruction we like at MIT Press. So since the publication of The Stack, our relationship with Bratton has grown significantly, and we've extended our collaboration to include Antikythera, leading to the creation of a new journal and book series that furthers our shared vision and builds off our past experience with JODS to a certain degree. The new journal embodies our joint commitment to innovation, pushing boundaries and fostering open knowledge. Moreover, it underscores our dedication to interdisciplinary research, bringing together diverse fields to address complex challenges. At MIT Press, we've always been at the forefront of publishing, consistently driving forward-thinking initiatives. Our innovative approach has led to numerous pioneering projects and publications that challenge conventional boundaries and explore new frontiers. We are particularly committed to digital publishing and emerging technologies, ensuring that our content is accessible and engaging in the digital age. And our collaboration with Antikythera and the launch of the new journal and book series really represents a significant step forward in that endeavor. And I think at MIT Press, we're really looking forward to what we're going to learn from this collaboration. So through these efforts, we aim to foster a community of thinkers and doers who are committed to advancing knowledge in new and surprising ways and driving positive change. And with that, I'll turn it over to you, Noah.
Yeah, thanks, Nick. So hello, everybody. Good afternoon. My name is Noah Springer. I'm the acquiring editor for New Media, Digital Humanities, Game Studies, Human-Computer Interaction, and Design at the MIT Press. It's a mouthful. But you might know me better as the acquisitions editor for the Antikythera series. Benjamin and I first started talking about this series a couple years ago, and he kind of positioned it sort of in relationship to his research, but then also broadening it out. And it was because of his success with The Stack, of course, that we said, oh, what else can we do with Benjamin? But given that we are kind of committed to interdisciplinary knowledge, boundary-pushing, forward-looking scholarship, the Antikythera series just felt like such a good fit. As we've seen throughout today and during the keynote, the fields that are combined within this series are just incredibly far-reaching. Computer science, architecture, philosophy, design, various sections of the humanities, as well as even science fiction, right? Especially Stanislav Lem, clearly the patron saint of the series, has really shown that its alignment with both my specific list at the press, but the press at large is really significant and kind of overwhelmingly along the same sort of agenda. And so when Benjamin and I started talking about this, we really thought that it was just such an important part to combine our efforts and really find a way to have the proper publishing avenues for the book series as well as the journal. And so the first book in the series, as you may have heard already, is by Blaise, Agüera, and Arcas, which is called What is Intelligence?, coming out next fall. You've seen the sample already. It's really emblematic of what the book series is going to be and what Antikythera is going to be, where Blaise is combining biology, chemistry, continental philosophy, neuroscience, and physics to help us understand the relationship between life and intelligence and where they collide and why that's important to understand in sort of ethical sense of how we start to live and continue to live. So I really think this is going to be a transformative book. It's going to be boundary pushing, and the series itself is going to continue to do similar stuff with the other projects that we have in the pipeline. So all that to say, I'm really impressed. I'm energized by the research and the massive output that has been generated already by Antikythera. And I can't wait to see kind of where this goes. And I really love the enthusiasm I'm seeing by this group of people, at MIT in the broader Antikythera space. I think it's been really exciting. So I'm proud to be partnered with them and for the book series. I look forward to a long and successful partnership. And finally, I wouldn't be doing my job if I didn't throw a quick plug for the MIT Press bookstore and our bookshop outside. So if you haven't already, please stop by. Will is selling our books as well as a couple other books. You'll recognize names from the fields represented here, as well as some other MIT faculty and things like that. And if you don't see something you like there, go check out the bookstore as well. I will never go a moment without trying to sell a book. So all that is to say, thanks for everybody for attending, and welcome our next panel up. Thanks.
Thank you, Noah and Nick. We're just as happy to be working with MIT Press, and so the enthusiasm is mutual. So I will, as mentioned at the conclusion of the previous session, this session emphasizes the Sapience side of the Planetary Sapience conjunction. I should say that unfortunately Sarah Walker will not be able to join us today, and so we will represent assembly theory in her stead the best that we can. Once again, let me give just a couple, sort of specify a little bit of our perspective and position and some of the animating questions we have around this topic as a way of hopefully teeing up a discussion that's just as interesting, as not more so than the previous, before I introduce our guests. So one way to think about this question of the planetarity of intelligence might be this way: to consider that over billions of years, Earth folded its matter to produce the very specific kind of thing, the biological and indeed now non-biological creatures, capable not only of craft and cunning, but also feats of scientific and artistic abstraction, all of which are ultimately geologic in origin. Now, in our moment, machines now behave and communicate intelligently in ways that were once reserved for precocious primates. Emerging from the evolution of complex life, a stable biosphere, and intricate perceptual and cognitive organs, intelligence is both planetary in scope and in origin. It is both contingent and convergent, as we have seen, and yet it continues and always will to take many forms, passing through forking stages of embodiment, complexity, and eventually even sometimes partial self-awareness. Over the last century, as we have seen on each of the days that we have been together, the Earth has grown something like an artificial crust of satellites and data centers and transoceanic cables, through which it has realized and continues to realize incipient forms of animal, machinic, hybrid cognition with terraforming scale agency. Now, as I mentioned in the Cliff Wednesday, our interest in this is not only on what these kinds of planetary technologies can do, but equally as much, if not more so, in what it is that they tell us about themselves, about the universe, and indeed about us. And many of the things that it tells us are not necessarily good news about all of those things on the list. Planetary scale computation has allowed for the sensing and modeling of climate change, for example, as our sort of key example, and thus informed the conception of an Anthropocene, quote unquote, and all of its existential reckonings. So the part of the irony of this, in a way, is that humans, or some subset of humans, had been terraforming the Earth for at least centuries before we understood that this was happening through the disclosures of planetary computation. In other words, agency preceded subjectivity, which is not always the way we teach it in our philosophy classes, but it may be where we should be looking at a way to hone and make more specific the questions that we ask. Humans and the species and systems that they cultivated were cultivated by, again, had been terraforming this planet, and so for this very, very long time. And through these artificial organs for monitoring our own processes that we continue to increasingly rely upon, there we also find not only ways or media through which we can know things. Once again, they themselves, those computational systems, are also capable of tremendous feats of cognition. And so part of the question to be asked is, what are the possible dynamics between these two forms of intelligence? And ultimately, not only how have they co-evolved together, but how may they co-evolve in the future, and what our role in orienting that might be. Planetary systems, both large and small, that is inclusive of human societies, have evolved the capacity to self-model and perhaps, hopefully, self-orient in one way or another. So part of the themes that you'll hear throughout this particular panel has to do with these dynamics of evolution. Evolution not only as the process through which we have all arrived here, but also the process, both divergent and convergent, that will define the future in which that we are both deliberately and accidentally composing at the present. And it's that tension, if you like, or the perhaps paradox between both the natural and unguided and blind forces of evolution and the, as I was discussing on Wednesday, the increasingly intense capacities for artificialization, which is in many ways highly guided, that becomes the way to question and perhaps understand the scope of that predicament. All of which our speakers today will address in unique and specific ways. So let me then, with that, introduce each of the speakers in turn, and then we'll ask them to introduce a little bit of the work that they've been doing with Antikythera, part of the thinking. And I think you'll see, like this morning, a way in which the mosaic comes to form in that process of thinking together. So to my immediate left is Blaise Agüera y Arcas, who, as Nick and Noah mentioned, is the author of the first book in the Antikythera book series, What is Intelligence? Co-designed James Goggin, and also the author of the What is Life, the extraordinary little book that you have on your chair there as well. And Blaise will be discussing both of these in some detail. Blaise is an artificial intelligence researcher, software engineer, software architect, and author. He is the CTO of Technology and Society at Google, and also leads a team working on fundamental AI research called Paradigms of Intelligence. He also founded the Artists and Machine Intelligence Group at Google some time ago. Before he joined Google in 2013, Agüera Arcas was an engineer at Microsoft and the architect of Bing Maps and Bing Mobile. Agüera Arcas has published multiple scientific articles, essays, op-eds, and books, including Ubisoft and Who Are We Now, both of which are available outside. And again, the forthcoming What is Intelligence, which you'll hear about this evening. To Blaise's left is Stephanie Sherman. Stephanie Sherman is a director, writer, and strategist who designs and develops collaborative systems across technology, urbanism, and culture. Her research focus on speculative histories, organizational architecture, platform automation, which you'll hear a lot about today, and urban AI. She holds a BA in English from Penn, MA in philosophy from Duke, and a PhD, which we first worked together at UC San Diego. She is also the associate director of the Antikythera program and directs the MA in narrative environments in the spatial practices program at Central St. Martin's. To her immediate left is Robert Pietrusko. Robert Pietrusko is a designer, composer, and educator. His research focus on geographic representation and the history of spatial data sets, he will share much of this with us today. His design work, quite extraordinary, is part of the permanent collection of the Fondation Cartier in Paris, has been exhibited in many countries and venues such as MoMA, ZKM, the Venice Architecture Biennale, among others. Recordings of his sound art have been released in various famed experimental labels as well. And he'll share also a bit of his current book project, High Contrast, False Color Landscapes of the Cold War, as a part of the history of planetary sapience that we'll also kind of explore, which is the real expertise of Thomas Moynihan, to his left, who is an intellectual historian at Cambridge. He works on the history of ideas, primarily the ways that changing theories about the wider universe have transformed human self-conceptions and practical priorities, which in many ways was where we concluded the last panel, and how those build a sense of our placement within the wider ranges of space and time and natural history, indeed, where cosmology and cosmology may come together. He holds a DPhil from Oriel College at Oxford, previously visiting research associate at history at St. Bené's College at Oxford. His prior work focused on the historical development of notions surrounding human extinction and global catastrophe, a discovery of the very idea of extinction, actually. Currently, he's at work on a project exploring how history's horizons have expanded throughout the past, present, and future. He's the author of two really extraordinary books, X-Risk, How Humanity Discovered Its Own Extinction, and Spinal Catastrophe. Very happy to have you all here. So with that, let me pass you the clicker, and we'll begin. So with my good friend Blaise Agüera Arcas will start us off.
Thank you so much, Benjamin. I'm really glad to be here, and it's a great honor to be inaugurating the book series and helping kick off the Antikythera journal. Benjamin and I have been working together for a number of years at the intersections of AI and speculative design and planetary thinking. And so the book that you all hopefully have picked up a copy of on your seats is a collaboration with James Goggin and Mariatsuka Minkyung-King and Johan Michailov, who are all, several of whom are in the audience now, to really explore two coupled questions. So, what is life is essentially chapter one of the longer What is Intelligence book that MIT Press will be publishing next year. So, think 10x this for what is intelligence. After we'd already gone to print with, and this was done on this is kind of like a rush job. We just decided that we were going to put out the little book 2 months ago. So we pulled it together pretty quickly as a standalone object. As probably many of you know, it's not the first of its name. So in 1944, Erwin Schrödinger, one of the fathers of quantum mechanics, made a book called What is Life as well. It was roughly the same size. And originally the plan was for What is Intelligence to be about the same size as Schrödinger's book, so overshot the mark a little bit. But we thought, why not take chapter 1, which really is about artificial life and about life more broadly, and its connection with intelligence, and the way life and intelligence are really continuous with each other, and break it out into a little Schrödinger-sized book of its own. So that's what you've got on your seats. We printed 1,000 of them, and maybe we can convince MIT Press to actually like put them on sale at some point. But that's in negotiation. But anyway, after we'd already gone to print with the little book, Benjamin pointed out that I actually hadn't answered the question, what is life, with the definition of life in this book, nor had I answered the question, what is intelligence, in the bigger one. So the manuscript is revised, but the definitions are not in this book. So I wanted to offer them here. Life, as I see it, is the computational phase of matter arising from evolutionary selection for dynamic stability. And intelligence is the ability to model, predict, and influence one's future, evolving in relation to other intelligences to create a larger symbiotic intelligence. So in order to make sense of either of these definitions, I thought I would just take a couple of minutes and walk through the basic argument made in this book without getting too long-winded about it. So first of all, the little book begins with abiogenesis, with the origins of life on Earth. Obviously, we don't really know what the origins of life were on Earth exactly. This all happened about 4 billion years ago, kind of at the earliest possible moment that it could, in the Hadean period, probably. As soon as there were seas on Earth and there was chemistry that could start to catalyze itself. There are two competing accounts. One of them holds that RNA came first, and the other one holds that metabolism came first. My belief is that talking about one of them as the origin of life is probably the wrong way to think about it, because in reality, life is a process of what Lynn Margulis called symbiogenesis, meaning the combinations of things in order to make larger things, or the composition of functions. So the moment you start to have molecules that can catalyze each other's production, in other words, where A can combine with B, and B can combine with C, and then C combines with D and also makes some of A, you start to have feedback loops. One recent scientific paper called this molecules and mutualism. And when you start to have such feedback loops, then they can in turn sort of mesh together almost like cogs to create a larger whole that in turn can persist more robustly than the parts can on their own. And then that becomes a thing, which can in turn engage in mutualism with other such things. And it's through a cascade of such symbiotic mergers that life emerges. And the bottom layer of that is just chemicals combining and forming these little loops. In fact, even that may not be the bottom layer. If you really think about the idea that life Kat Hales talked about this morning. Life is really about perpetuating, about its own persistence over time. Even something as simple as an electron or a quark is really just a stable object that can persist in time. We don't really know what the basement layer of physics is. Maybe it's quantum field theory, maybe it's strings, maybe it's some other thing that we don't understand. But we know that many things are possible at that very bottom layer that are not realized. And that the things that we do see realized are the things that have persisted. And so if you think about it, that persistence and the fact that those persistent things can in turn combine to form things that themselves persist the way quarks combine to form nucleons, and nucleons, and electrons combine to form atoms, and atoms combine to form molecules, and molecules combine to form polymers, and so on. It's kind of the same story all the way down. And in that sense, evolution, if you think about it in terms of dynamic stability, might be a much bigger story than biology, and might even account for the anthropic principle, meaning physicists have talked about the anthropic principle in terms of the apparent fine-tuning of the universe for life, but that may have things backwards, in the sense that there may be many, many possible universes in which things can persist, and when those things that persist combine to form things that can persist better, then life as we know it may be the outcome of an evolutionary process that is automatic under very, very general conditions. So what are those really general conditions? Well, we know something about life and its computational nature, and we've known it for a long time, since von Neumann in the 1940s, 1950s, but this isn't well appreciated. Alan Turing and John von Neumann are really the heroes in some sense of this book. They both are known, of course, as the parents of computer science and also of AI. The Turing test has become very famous in the last few years as sort of an objective, functional measure of when we achieve intelligence. Intelligence is as intelligence does. I guess I think of myself as a functionalist as well, in the sense that the way things function in their environment, in their context, is ultimately, what we mean when we talk about something being intelligent. What is not so well known is that both Turing and von Neumann were also theoretical biologists. They in a way founded theoretical biology too. And von Neumann's contribution to that field was the idea of self-reproducing automata. So a self-reproducing automaton is a robot that paddles around on a pond where there are lots of Legos floating around, and it assembles those Legos to form another copy of itself, which is a remarkable thing for a machine to be able to do, right? There's something a little bit paradoxical about the idea of something literally building something as complex as it itself is, but of course that's exactly what a bacterium is, or what any other form of life is. The paradox of life, in part, is the paradox of being able to make something as complex as you yourself are. And what von Neumann realized is that would require having a tape, having an instruction tape with instructions for building yourself inside yourself, and then having what he called a machine A that would follow the instructions on that tape in order to assemble the Legos into yourself, and also having a machine B that would copy the tape itself. And finally, the instructions for building machine A and machine B have to also be on the tape. If those conditions are met, then you have a self-reproducing machine. Now, he came up with this idea before the structure and function of DNA was discovered. But of course, he called it exactly right. DNA is that tape. And machine A, by the way, is a Turing machine. So there is literally a computer at the heart of anything that is alive and that can evolve. This is evolvable in the sense that modifications made to the tape persist through the generations, and so you have a basis for evolution to happen. So what you see, the video that you see playing on the left is an experiment that the book goes into some detail, and I won't go into detail here because we don't have time for it. But it's a computational experiment in how abiogenesis happens, how it is that function and purpose arise from pure randomness. And in this case, that happens via a bunch of tapes in a soup. Those tapes begin with random bytes on them, so with no structure and no function whatsoever. And the only thing that happens is that you take two tapes and join them, and then run it as if it's code, and then take them back apart and put them back in the soup and repeat. And when you repeat millions of times, programs emerge that are quite complex, and it takes some time to reverse engineer. And their function is to reproduce. Reproduction comes about automatically because that's a way that something can persist through time. If you have something that can't reproduce, then your likelihood of seeing it again in the future is much lower than if you have something that can reproduce. And in that sense, the stability of reproduction is actually one and the same as the second law of thermodynamics, which is kind of the answer to the puzzle that Schrödinger posed in the 1944 book, What is Life? His puzzle was, how could life exist in a universe where everything tends toward the stability of randomness? And the answer is something that has a model of itself and that can reproduce itself, can push back against the second law and actually creates order and structure in the world. But it's actually just another form of the second law, just one in which you think about the stability of cycles rather than just the stability of fixed points. And when you combine that with the idea of symbiosis, wherein things that have solved that problem of perpetuating themselves can combine to perpetuate jointly even better than the things can on their own, now you get the ladder of complexification. So that tells you not only why life arises in the first place, but why life becomes more and more complex. And finally, intelligence is what happens when something that is able to compute is able to not only make copies of itself or grow or reproduce, but is also able to form a model of itself and its environment, is able to predict itself actively into future existence. And again, Kat Hales said this extremely well, right? Intelligence is the ability to form a model of yourself and the environment jointly and auto-complete yourself into existence in the future. And the more sophisticated the symbioses that bring together intelligent entities, the higher order and longer term that prediction can become, a process which Benjamin and I think both believe has become planetary at this point in time.
Always was.
Always was. Always was. So, it's been said sometimes LLMs or, chatbots are just autocomplete. I agree with that statement, except for the word just. I think that life itself is autocomplete. We are autocomplete. And in a sense, autocomplete is a lot more than we have heretofore understood. And even phenomena like consciousness can be understood in terms of a self-model that arises through social interaction and through applying that to oneself. And those are some of the points that are made in the bigger What is Intelligence book. So moving on.
Stephanie will speak to the auto in autocomplete.
Hi, everyone. So my contribution to Antikythera's new journal with MIT Press is called Auto, Fortean Prehistories of Planetary Platform Automation. And the project follows the planetary pivot towards mass automated platform production on the Fortean assembly line in 1908 through to the coining of the term automation in 1947 at Ford Motors. And the project operates as a speculative robot history, in the words of Manuel de Landa, exploring how the persistent pathologies and latent possibilities of this era shape automated intelligence and the future of physicalized AI, such as autonomous vehicles we have today and those to come. And in general, it uses the kind of paradigm of automobility to question the basic paradox, dare I say fetish, at the heart of the auto more broadly, a phenomenon that sort of suggests always independence, but that really always refers to an interdependence that controls the independent reproducibility. So the project takes on these two terms, platform and automation, and puts them together. Firstly, platforms. Platforms, you probably think of them, are recognized as apps that match two-sided markets or software systems. But the project kind of thinks about platforms as a general systems type that traverses geology, architecture and infrastructure, communications and stage. Platforms exhibit particular logics and dynamics that we can see playing out across all these different typologies. They use standardization and homogenization to flatten complexity into a foundational layer, which then generates further complexity. They combine seemingly contradictory patterns of consolidation and rupture, performance and persistence, centralization and decentralization, not as opposites, but as a hybrid. And in Sarah Walker's parlance, platforms create what we might think of as scaffolds that allow other things to emerge and appear. So, secondly, automation. Automation is typically understood as a form of substitution of human labor by machine. But following Bucky Fuller, we can follow the definition of automation more expansively, as a general evolutionary principle, whereby an action in a process that was once debated or deliberated in each instance gets resolved and solidified over time into protocols, so that parts of the process function without a human operator, independently. According to Fuller, biological and ecological systems, planetary systems, are all already automated. And rather than seeing automation as a function of human replacement, we might view automation as a logic of delegation, cascading functions as to who and what does what and what roles they play. So Fordism, and the automotive complex they wrought demonstrate well the persistence and pathologies of this systematic arrangement. Platform automation at planetary scale, developed through evolutionary technological iteration, not only autopoetically and unthoughtfully generated a planetary machine space of pervasive automobility machines, it also set in motion the same factory-scale principles that eventually give rise to computation and simulation. And probing that history from a post-human perspective, it produces, in a robot historian sense, it presents parables and primal scenes of precursors to automated intelligence. For example, now with our purview, we might view workers on the assembly line as humans playing at being machines, a shift that precedents the shift from cars as once machines to autonomous, diverse networks of robots. So the bigger implication of the project is this. Rather than think about autonomous vehicles per se as individual agents of control and decision, we probably want to think about them as swarms of a vast distributed mobile urban sensing apparatus, computer nodes that humans ride in, connected to the computational city and planet, that occupy an infrastructural machine space that we've built, a platform that we have now precedented, that we can't take away, on a new automated stage. And the key diagnostic that drives the project that we might take into the new formations of automated intelligence as we think about them is seeing the design challenge not as that of designing a device, but rather as design of the environment. And the kinds of constraints that if we focused on the environment rather than the individual agent or device might afford and generate. So looking back on platform automobility and towards the future of physicalized AI in the shape of autonomous vehicles of hopefully all sizes and shapes, begs us to consider intelligence not only as the capacity for decision and models that can adapt to various environments, but autonomous intelligence as an embedded environmental ecology, a sort of platform unconscious that exchanges rigidity for certain virtuosity. And in this way, the paths of platform automation can manifest the most grand forms of ecological intelligence or utter stupidity, as the automotive complex perhaps shows us. And these dynamics start to map the challenges for the Sapience unfolding before us.
Great. Hi everyone. Like Nicholas this morning, I'm of that kind of class of designer who has this compulsion to historicize. So there's going to be a lot of that here, a lot of throwback stuff. But also a throwback to the morning session, a bit of a recapitulation of some of the themes that showed up then. For my specific interests, about how knowledge of the planet was also tied up and entangled with using the planet to derive knowledge of other things. So the planet as an epistemic thing, if we might call it that. I'm specifically interested in the landscape, that thickened 2.5 dimensional surface of the Earth, and specifically how it's been used by ecologists and military strategists alike as a communication channel through which otherwise inaccessible information might flow. This is part of a project that Benjamin alluded to earlier that I've been working on for the last several years, where I'm trying to understand the remoteness of the term remote sensing. Far more than a synonym for just distance or altitude, remoteness is an epistemological category. It's a designation of inaccessibility that came from the geopolitical blockages and desires for planet-scaled information that emerged during the Cold War. And to drill into that just a little bit, I mean, it's a term that was coined in 1961 by Evelyn Pruitt in an otherwise unremarkable budget meeting about a series of reconnaissance projects over the last decade in the 50s. And she meant it very much the way that I'm talking about it now, inaccessibility and the problems of planetary scale. So crucial for this work is vegetation. I'm interested in the vegetal landscapes depicted in aerial photographs, and the ones that preceded more contemporary remote sensing systems. Specifically how vegetation shaped the knowledge derived from these images, and how vegetation became a communication channel within a larger chain of information capture and processing. In my analysis, interpretation of remotely sensed images had a particularly botanical flavor. This has to do with actual botanists working on it. One that informed early models of human decision-making and cognition, as we'll see, and also informed techniques of pattern recognition that remain with us today. Over the last decade, I've been looking at the early years of the Cold War, when botanists collaborated with US intelligence analysts and used plants and tree species as surrogates for information about politically inaccessible landscapes. I'm going to quickly describe one aspect of this work at three. I'll present them separately, but these are three highly interconnected sites and scales. So 3 sites, 3 scales, 3 slides. This is site and scale 1. We'll call it the planet. Scale 1 to 100 million, more or less. I don't know. Okay, so how's that? Big enough? So naturalists have long recognized that at the global scale, similar patterns of climate, elevation, geology, etc., result in similar vegetal cover wherever they occur on the globe. This is, many of you probably know this, and it's resulted in the concept of natural regions. We see these maps all the time. Now, during the early Cold War, however, these findings had a new significance. The US military anticipated a ground war with the Soviet Union and required information about the Eurasian landscape. But of course, they couldn't access it. And botanists and geographers documented how vegetation covered vast territories with extents that ran completely indifferent to geopolitical boundaries and borders. And we see that here, the similarity in East and West in these images. So observing where similar vegetal patterns existed in the East and West, botanists created numerous test sites in North America that served as proxies for specific locations in the Soviet Union. And they believed that militarily useful knowledge derived from plant cover in these very specific sites would also be applicable to the denied territories of the Sino-Soviet bloc. Okay, next, site 2, the ground. This is roughly 1 to 20,000 is scale. So I'm talking about vegetation as information, but for these folks, what useful information could actually be gathered by vegetation? What could vegetation provide? Vegetation created a second proxy at a radically different scale. From an aerial perspective, vegetation seemingly obscures the ground, right? Seems evident as an optical thing. But plant and tree species also communicate many qualities of the ground that they cover. So things like slope, soil type, moisture, and firmness. And they even reveal characteristics that are not visible to either a grounded or aerial observer. And these are things like the depth of permafrost or the height of the water table. And so importantly for analysts at the time, all of these characteristics that I just described were seen as militarily useful because they affected mobility. And at each of the North American test sites, and we have some evidence of them here, botanists created strict correlations between vegetal cover and underlying terrain qualities. And we can think of these as early associative models, right? This kind of very strict correlation between plants and what they would reveal. At the same time, photo interpreters made strict correlations between plant names on the one hand and the tones and textures that you see in the aerial photographs here. Based on these correlations, analysts believe that aerial photos of vegetation could be used to map military terrain anywhere in the world without ever having to access the ground. All right, so we have these test cases at one scale that produce vast territories when deployed. And that brings us to site and scale 3, which I'm calling the interpretation lab, and we'll say that this is at 1:1. The correlations between photographic patterns of plants and their underlying terrain conditions were codified in diagnostic keys. And it was great that Blaise, in your slide of what is intelligence, showed one of these keys, actually. Not one from this context, but that diagram of a series of binary demarcations of this versus that, a sort of decision tree. So each of these keys led a photo interpreter step by step through a series of yes-no decisions about the visual sensation that they were experiencing when looking at the photographs. They don't know anything about plants, but they can register if the texture is this dark or this light, if the texture is modeled or something else. And after going through this chain of binary decisions, the plant species that they classified is revealed, and the resultant ground condition is said to be mapped. Now, of course, naturalists had long used diagnostic keys to identify plants themselves, but the technique was now extrapolated to aerial altitudes and applied to photographic gray tones. And in short, it became an algorithm for rapid information processing that allowed unskilled interpreters with no botanical expertise to act as sensors and to classify thousands of aerial photographs, pre-computer. Now, this had two results that are relevant to concerns, I think, hopefully today, stitching together a little bit of the Planetary and the Sapience. First, this directly informed the development of decision tree analysis, one of the first pattern recognition techniques developed in the 60s. And classifying remotely sensed images was one of the first problem domains for these algorithms. There's a very clear historical lineage between these projects and those algorithms later. And then second, it changed our understanding of what it meant to even map a landscape at the regional or planetary scale. A literal map was no longer necessary or even the goal. It was now replaced by a classification procedure, or we might say an algorithm that was informed by vegetal proclivities. And this algorithm could be deployed as needed. From the standpoint of a military apparatus that required terrain information at a global scale, regions were said to be mapped if a vegetal diagnostic key for it had been created. And then only the decision algorithm was necessary to produce terrain information anywhere in the world. So this, for me, is that relationship between the natural landscape as kind of an epistemological thing or an epistemic thing that produces planetary scale and then relates to models of cognition at the time. We might, many of you probably know this better than me, but of course, like the atomic bit of information is the ability to make a decision, as Shannon describes it. And it's precisely that understanding of yes, no, 0, 1 that's embedded in these diagnostic keys. So hopefully the short vignette suggests a little bit of my curiosity about how cultures of vegetality preceded and informed early cultures of digitality. Thank you.
Hi, thank you all for being here, and thank you to Antikythera and MIT for hosting some absolutely mesmerizing presentations so far. Peeping into a black hole, witnessing abiogenesis, car crashes in GTA. Absolutely mesmerizing. So I'm going to end with a scatter plot graph. I don't want to undersell it. So our species is the first to ask and begin answering the question, where is now? That is, how much past was required to produce our living present, and how much future might be left ahead, waiting to be produced. Such questions are important. We are orienting creatures. We seek to know the world and our place within it in order to better navigate our way through it. Obviously, one way to orient ourselves is to seek our place in space. We now know that we live on a planet that is pirouetting around a star that is one amongst many, in a galaxy that is one amongst many. But as you can see here, another way to seek orientation is to seek our place in time. And this is a crucial consideration because time is the medium within which actions come to matter, within which what comes before comes to influence everything thereafter. So figuring out the ambit of influence of how far it stretches behind and ahead is a crucial decisive factor. If I knew I was going to die tomorrow, I probably wouldn't bother securing a mortgage today. But such chains of reasoning need to be extended now beyond ourselves as individuals up to us as a planetary collective, given that we are now, as a species, a planetary agent of change, potentially dictating the entire future for the biosphere. But answers to the question of where we are in time have obviously changed over time. This project aims to visualize this. So some backstory here. Over the years, in my travels through the archives researching the history of ideas, whenever I came across someone making a prediction off the cuff, or perhaps more seriously, about how much past there was behind and how much future might be ahead, based on extrapolations from physical process, I recorded it. Over time, this amassed into quite a large data set. And so eventually I asked myself, well, how could I visualize this? How could I communicate this? And so what we have here in the center is my back of the napkin prototype of how this might work. So we have the central axis, and this is plotting human history. So 1600s, 1700s, 1800s, up to our present. And think of this as a series of consecutive nows, of consecutive present moments. And then stretching out from this, below and above, are those then contemporary predictions on how large the past was and how large the present was. So, I am nothing very far from a data visualizer. I have no skills in this department. But using the crude tools available to me, aka Microsoft Excel, I tried to put this data set into a graph. Here's the scatter plot. And so here on the left, you can see the first attempt at this. And so I've got, as the key shows, nested types of predictions. So along the bottom, developing predictions of the age of the universe as a whole. And then above that, age of the Earth, some other ones that I can skip. And up the top in the future, predictions on the future habitability of Earth. And at the very top, predictions of how long this universe, writ large, can host complicated life. In the center here, we have a bit of a zoomed-in close-up that can give you some sense of what I was trying to do here, because I guess, the text is very small there. And I should say the one on the left is a logarithmic scale. So that was me trying to fit all of this onto one screen, because as you can see, the one behind me on the right is non-log. And I think that you can see from that just how much our sense of how long the future might be has ballooned in the past century, given, I would say, the coming of age of cosmology and its increasingly eye-watering predictions for how long this cosmos as a whole might be able to host complicated things like you and me. Again, as I say, I am far from a data visualizer. So the kind people at Antikythera have partnered me with Lisa Strausfeld of Information Art, an absolutely masterful information architect, to create, to make this into not just a workable object, something that can fit on a screen, but also an appealing one. And here is the visual identity that Lisa has so far produced for what this is eventually going to be, alongside the working title, The History of Now, which is more or less self-explanatory. And actually, I owe to Benjamin, you were the one that suggested that title in conversation. And so we've decided that the vertical axis is now going to be the human history axis. And so as you scroll down, you're scrolling through human history, and as that goes by, various predictions, contemporary predictions for how long the past was and how long the future might be, will stretch left and right, respectively. And so as you scroll through human history, these will compile these different predictions, and eventually the user will get a synoptic sense of how our sense of our position within time has itself changed over time. And so the final product will have text as you scroll through on your journey, narrating the major step changes and the key discoveries in science that have forced major shifts in our sense of where we are in time's wider expanses, alongside images of contemporary illustrations of the physical processes involved, be it planetary accretion or the Big Bang in the past, and various speculative kill mechanisms putting upper bounds on Earth's future habitability in the future. And so I guess, yeah, we all are conscious of our own biographies. We have a sense of their probable bookends and the placement of our current moment within them. And I think that's a very important part of what makes us such potent agents. And so if, as Antikythera argues, we as a species are a conduit of an emerging, coalescing form of planetary intelligence, it's only right that we bequeath the globe itself a similar aptitude. And so this project aims to chart that process of how, through us, a planet itself becomes conscious of its own unfolding biography. I think it should be something special. Thank you.
Thank you all so much. I mean, it's mesmerizing indeed. Thank you all for these, and thank you so much. So I'll try to kick things off in a way similar that I did previous of some of the links that I'm beginning to see, so the questions here as well, and then throw it to you all, and we'll kick the ball back and forth, and I'm sure it's sort of fun. So the question of scaffolding, I think John Maynard Smith maybe from this is in this as well. So it has something to do with sort of the things that persist and therefore become components and yet more complex things. Like one of the phrases I think each of you said at one point was further complexity. That complexity begets complexity, which begets complexity, and that the conjugation of form over time is one in which not only does you pass through these sort of threshold phases, but that the previous scaffold persist. They persist through this entire kind of dynamic, and they become in a way a stable component which allows for autocomplete, automation, all these sorts of things to literally repeat themselves over time. Persistence is repetition in this way. I was also taken by a phrase that you sort of said very quickly, Stephanie, about physicalized AI, which is also sort of something we looked at in the Cognitive Infrastructure Studio about how we may be very quickly passing through the end of the phase in which we may have thought of and conceived of AI as a kind of disembodied brain in a box, a kind of voice in a petri dish, but rather something that is animating things in the world, which will then undertake their own kind of complex evolutionary dynamic on their own, and that link between the physical and the virtual. But one of the things you said was also that the ways in which that there was a kind of physical form of computation with of automation, with the assembly line that established a kind of platform logic of automated component parts, which then gave rise to the possibility of the forms of planetary computation on which obviously these supposedly virtual things exist, which then is perhaps folding back into the physics. So we have a physicalization. Like a physical process becomes a virtual process becomes a physical process, and they sort of work together. One is scaffold of the other in ways as well. Also totally fascinated by the kind of secret history of AI and landscape photography and the kind of structures of incremental decisions that this works in advance. But the thing I want to sort of leave with is the last, I think, thing we may want to touch on is the future, the question of the future and the ways in which each of you deal with this as well. If Sarah were here, one of the things that she might contribute to that discussion is the argument that within assembly theory, the most complex things in the world are the ones that contain within them the greatest number of scaffolds. Therefore, they are the ones that contain in them the greatest number of steps that needed to be taken for them to exist. Therefore, the most complex things, our technosphere, is the thing that contains the most evolutionary time within it. And in that strange sense, they are the oldest things in this regard. But the way in which she would describe the future then is it's something by definition is more complex. That further complexity is the same thing as futurity, and the futurity is the same thing as the future. Now, you talk about futurity as one of the terms in your fundamental definition of intelligence, the ability to predict not the state in which the agent is in, but a potential counterfactual future states, to predict the future or model the future and in fact choose between us. And so complexity equals futurity, futurity equals intelligence. There's some sort of, again, way in which these things are sort of converging and aligning in strange ways. So I wonder if we could anyone who wants to jump in and find a thread to pull on, please do so.
This is a great series of threads and provocations, I think. So, one of the things that appeals to me most about how Sarah talks about assembly theory is this idea of things that are most complex today also being the oldest, in addition to being the most recent. So they occupy a very thin bit of history in the very recent past, but they also are the deepest in the sense that they are the most contingent on a deep history, and the deep history is still always there. This is an idea that I feel like in a way has become a little old-fashioned, because it's sort of the idea of progress. It now sounds kind of mid-20th century, like we're so over progress, and I think that that's a real loss of understanding of something very basic. So I'm thinking about the way, for example, Stephen Jay Gould, has spoken about no thing being more evolved than any other living thing. We've all been evolving for 4 billion years, so everything is of equal age. It's not true. It is literally not true. We are colonies of eukaryotic cells, which are themselves composed out of a bacterium and an archaeon each, and those smaller things, we're like a kind of matryoshka dolls, and the inner versions of that, the sort of more you zoom in, the deeper in time you look, and that's true even for the ribosome, for instance. There's a beautiful recent work showing that the core of the ribosome is the oldest part and is the most evolutionarily conserved. And there have been sort of layers added to the outside of the ribosome. You can date, the evolution of the ribosome kind of geometrically as distance from the core, and that makes sense because any innovation has to rely on a combination of existing parts, which is also one of the reasons that we always get simultaneous discovery. In science and in technology. So there are many famous examples. The light bulb is one of them. It was multiply invented, about a dozen times within the span of a few years, and is subject to a lot of lawsuits because of that. Why did it seem like everybody was in telepathic communication? At this moment, and they all invented the light bulb at the same time. Well, it's because you can't have a light bulb without having electricity and without being able to draw metal filaments and be able to make a vacuum and blow glass. And the moment you have all of those parts, it's almost inevitable that set of ideas is going to recombine in this form. Of course, it takes intelligence to do it. Because we're not just in a world where glass and filaments and electricity are bumping around the way molecules did, at the bottom of the sea 4 billion years ago, randomly combining.
But
These
once
are
all the pieces are
abstractions.
there, they're gonna.
But once they're there, that's right. Once they're there, any intelligent being that is exposed to all of those things and has a bit of imagination will come up with it.
Yeah.
And it couldn't have happened earlier because the pieces weren't there.
So this connects in it with something that Thomas works on quite a lot, which is the dynamic between, or the sort of fragile balance between path dependency and contingency. What you're talking about is a kind of path dependency. Once you get a certain scaffold structured in a certain kind of way, the space of likelihood of their trajectory, maybe not their progress, but their trajectory is so weighted that something might occur in this.
Although not technological determinism, to be clear. Like, even if we look at the light bulb, there are these interesting things about, like, for instance, does it have prongs or does it screw in? If it screws in, does it screw in clockwise or counterclockwise? At every moment of combination, there are also choices for Brian Arthur.
This is what I mean. Is that, well, there can be many determinisms at the same time. But I mean, recognition of the path dependency, which is in a way what automation is all about, is trying to eliminate the contingencies of path dependency. Doesn't mean you get rid of contingency or randomness in this. But on the simultaneous discovery, I sort of make there's a couple books out here. My favorite series of MIT Press is the Vienna series in theoretical biology, which I happen to think is the most interesting philosophy of technology series. And there's a whole, convergent to evolution is really the thing that this is sort of known for in this way, which is a topic I'm going to bring up. But on the question of the inevitable or the evitable, this dynamic path contingency. I mean, something you've thought quite a lot about. I wonder if you could also locate your thinking in relationship to what Blaise has sort of posed for us.
Yeah. So I guess like the graph thing is like a canvas against which what I actually find interesting, well, within which what I actually find interesting unfolds. So it's like, I use the word upper bound. Like it's very much, in terms of selecting the data, I have tended to use like scientific estimates, and that's why I said extrapolations from physical processes. So it's not like I'm including someone in a newspaper in 1870 saying that Jesus is returning tomorrow and the world is going to end. Far be it for me to denigrate that. But I'm more interested in the scientific, like that view, which is like an upper bound. It's like a canvas within which the future could possibly unfold. So, current science tells us that the Earth may remain habitable for something on the order of 1 billion to 1.5 billion years, given the expansion of the sun and the eventual ramifications that has on our atmosphere. But that's an upper bound, and within that, there's a whole range of contingency. So it's like all of the ways in which everything could play out are like unimaginably large. And so, yeah, that's what I find interesting. And so, I guess I did refer to it a bit, but, I think, again, a very strong thread that brings everything that, particularly in the planetary sapience aspect of Antikythera, does together is almost finding analogies for what, say we are creating a planetary intelligence or something of that sort. Finding analogies between what that type of intelligence is and the type of intelligence we are. So I kind of draw on this biography metaphor. Like I said, we know the bookends of our biography. We all know that we will, on average, live an X number of years. But again, that provides the canvas within which we conduct ourselves, and I think it's an important orienting thing. And again, that's where contingency unfolds. I care about not getting run over because I know that hopefully I could live for a further few decades. And I think we need to extend that type of thinking to the planetary. And I guess like a final point is that's the condition of responsibility, right? Is we think of ourselves, I guess, a metaphor I keep thinking of as a Bildungsroman, right? Like it's this kind of narrative form where a person kind of narrates to themselves their life as a way of acknowledging that they were an agent that created it, so therefore they can kind of write the future of their life. And so, yeah, I would like to see, I'm interested in this idea of what does that mean at the planetary scale, and that means really coming to terms with path dependency and these contingencies.
And the composition of this, I have a question. I want to sort of put on for Bob to think, like this relation between design and contingency, and what's at stake for this. That's a question I'm going to ask you in a moment. But I did want to sort of turn to Stephanie on this and around the automation, and ask you to sort of expand a little bit on something you sort of said really quickly, referencing Fuller. Which is that complex ecological systems are already a kind of automation, and that the forms that we are making are sort of an artificialization of this. But I wonder if you could expand on that a little bit further, and also, the way in which you talk about automation itself as a kind of distributed intelligence. Please.
Sure, and a couple of stories maybe to bring that question and these two ideas together. I think in Fuller's case, he's really talking about embedding, right? Like, so there's a series of processes that get formalized into protocols, and then they get embedded, and that embedding or encoding, as we might think about it, is kind of then a perpetual process. And I'm thinking about this in terms of how time gets internalized, actually, that like there's kind of like an absorption of time into the process where then it actually doesn't need to be calculated anymore at any level, because the calculation is like embedded or encoded. It doesn't need to be a conscientious calculation. It's immersed. But a few things that I wanted to pull on from that question, like, so the Fordist assembly line comes around because really Ford has the capacity to make the machines that make the components. So there's enough capacity to actually standardize all those components that allows that production to actually flow in one continuous process. And The other thing that about time that I was thinking about is Herbert Simon's watchmaker's parable, which is really about how it's actually not all the sets of individual components that can be infinitely like put together in any which way, but actually the components congeal. And so the watchmaker's parable sets up these two conditions where there's two watchmakers and each of them gets interrupted in the process of assembling a watch with a phone call. And the question is, why does one watchmaker achieve assembling the watch much faster than the other watchmaker does? And the one that does assembles all these little parts together. And so when the phone call interrupts the watchmaker, that actually all those little constituent assemblies can just be put together. They don't have to start from scratch during the interruption. And I think that's actually a really astute way to think about what's happening now in terms of constituent parts, but also the kinds of things we might want to design that actually where like one part within those constituent parts gets substituted or interrupted, or like what are the forms of interoperability in which the constituent parts might come together in different ways. We don't want to go back to like all the components spread out on the table anymore. We not only can't we, but that's actually not maybe the right way to move around. Finally, just one last kind of story about kind of this evolutionary process perhaps is that even though on the Fortis assembly line they're experimenting with all these different time dynamics and constituent parts put together, the real story of the assembly line is about a fire. And they have to pull everything out of the factory because there's a fire in the plant, and when they put it all back together, that's actually the moment that allows the kind of interoperable time dimension to really happen. And so I think it's not only that there's like continuous complexity building on complexity, but there's like iterative complexity punctuated by incredible disruption, and that those disruptions allow us to then understand complexity in a new way, and maybe that's what we're going through right now.
So I want to ask Bobby about, so you talked a bit about the sort of the composability of the future, there's another, which is really what, I mean, your as a landscape architecture program, like this is what design, especially in this kind of experimental academic context, is sort of about, of experimenting in sort of like how is this composed? Now, in your practice and in this sort of work, you know, the relatively modest sounding project of landscape architecture really has to do with like designing ecologies, designing ecosystems. And maybe to Stephanie's point, it's not about what we might traditionally think of the work of an architecture school designing an object, but rather designing the system that would set in motion the trophic cascades that would eventuate into this object. And so I wanted to speak to this as well, but also in response to this, one of the things I've seen lately, you know, this is over the past couple of years, really sort of more so, whenever I visit a lot of design schools, and it's sort of a do, is that there's almost a kind of unspoken presumption that in a way the world is over, and that the best we can do is to sort of like remake the ruins in some sort of very modest and apologetic way. And to Thomas's publication, it seems like that's like the worst thing to be like a horrible time to go to design school. I wonder if you could talk a little bit about what you see as a sort of the large, like what is the proper horizon for composability that actually could match the moment of this, what is inevitably a kind of artificial future?
Yeah, more or less.
How big is big?
Big is big. Okay, so let me get my head in order here. Let me say a few things about a discipline, which is not what I thought I was going to be talking about.
You can answer a completely different question if you want.
Maybe I can shill for the, if we're talking about horizons, I can sort of shill for the affordances of a discipline that it doesn't quite sort of live up to at the moment. And so I didn't study landscape. I studied architecture, I studied signal processing, studied computer music. Just through some weird contingency, I ended up, but it suited me. And there's a way that I think, exactly as you said, the idea that trying to work with natural systems, even modeling natural systems, and simulating how they might unfold in time with all of the kind of uncertainty that implies is sort of at the core of contemporary like landscape pedagogy and landscape thinking. And yet at the same time, there's a conservative streak in landscape that I think you've properly acknowledged, which is just a mournful modesty that's either retreat from everything or restore everything to some weird moment that was just kind of chosen almost randomly in the 1700s, at least in the US landscape. And I think the way that all of you are sort of talking, the kind of temporal dimension, these multiple paths, the way that like units can be combined and result in unexpected emergent properties, that really is, I think, the potential of landscape as a design discipline in a way that I think makes it attractive to folks outside of it. And I actually see that there's far more compelling landscape projects being done in fields adjacent to landscape. And I don't know, do I get fired now? But I think it has a lot of potential. Now, in terms of like specific time horizons, there was actually I saw a conversation recently, like Jim Corner was actually talking about he was talking about fresh kills recently, and there was a question about like, did it work? Did it do the thing you were thinking of? You know, and he's like, I don't know, we built we let topsoil grow. That was the project, and then however it evolves over the next 100 years, like that is the project, and we can only observe. And I feel like it's really, I think the sensibility is quite similar. That there's a creativity, there's a series of paths that might be pursued, and it's sort of a collective enterprise. And I don't mean collective just like human, but collective, all of the kind of matter and energy relationships that are entangled in it are going to determine what that is. And I find that's incredibly powerful. It's an incredibly powerful way to think in design.
Yeah, more broadly, and not just architecture. What are the things in your definition of intelligence that I wanted to ask you a little bit about, also, which I think connects with what you was just saying, is the way in which this sentence is written is the sort of intelligence is something that does this sort of in relationship to other, right? And so one, like, probably incorrect maybe way to read the sentence would be that in a way there's a kind of formation of intelligence, an agent, that then subsequently, later on, next week, enters into these kind of dynamic relations with other agents, one way or another. But the way in which you usually talk about it, it's the other way around. Like that there are these interactions and things like connecting with each other and disconnecting, modeling each other one way or another, that then eventuates in the intelligence of the singular agent, which actually I think is what you just described in terms of the intelligence composition. Am I reading it wrong, or how would you like to unpack that? Like, help us understand that. Yeah.
It's both.
Yep.
So intelligence and life, for that matter, because they both have this kind of recursive quality. They don't exist in isolation. And actually, if Sarah were with us, on the panel today, which I know she originally was slated to be,
indeed, yeah.
She would undoubtedly talk about copy number. What she means by copy number is that the idea of something being alive or having been selected for implies that there has to be more than one, and ideally there have to be lots.
Right. For things that exist are. They exist because they are the things that exist. Yeah,
right. Well, and in particular, if they exist and they're non-trivial, then they probably exist more than once because their existence implies a process by which they come into being, and that process is going to kind of operate over and over. And that being the case, all life and all intelligence are inherently social, because your environment as a living thing is always other living things. Your environment as an intelligent thing is always other intelligent things. Intelligence doesn't have to arise in order to, survive in a sort of, one-player game, a la, Grand Theft Auto, where everything around you is an NPC. It arises because you have to model others, and the modeling of others is automatic, and it happens even with plants, even with bacteria. It's always social. It's always in relation to other things that are themselves also modeling. And when we talk about this psychologically in humans, the word for it is theory of mind. Although I get into a lot of trouble with linguists, with cognitive scientists, when I use the term theory of mind for something like a bacterium or a plant. But I, and I also get in a lot of trouble with biologists when I use words like symbiosis, applied to, AI modules or chemicals. But I'm going to stick to both of those. So theory of mind is being able to model what is going on in the mind of another. And then you say, well, how do you know that other thing has a mind? Well, you don't. Everything has a perspective. But if that other thing is modeling you back, then you also have to have a model of its model of your model, and so on. And so there's a second order, third order, fourth order, et cetera, aspect to all of this. Us humans, we can go up to sixth or seventh order normally. There are psychological tests for this. The Sally-Ann test is the common one. Monkeys probably only first order. Some of the great apes second order. But it's one of the special things that we have developed as humans, the ability to do this high order theory of mind, which is one of the ways that we can organize ourselves into larger constructions like cities. So I've never thought of human intelligence as being an individual human property at all. Individual humans are not that smart. And in fact, if you were to land on Earth as an alien 50,000 years ago, I doubt that you would see humans as being particularly different from a lot of the other megafauna around. It's interesting how not all that much seems to have happened up until the glaciers retreated the last time, and for a variety of reasons, things began to really spiral upward socially. And that was driven by theory of mind. What we think of as human intelligence, we say, the great achievements of human intelligence, Kenneth Clark or whatever, they're not really individual. They're products of us modeling each other and doing division of labor, which involves modeling of others, and thereby creating a superintelligence, which is humanity as a whole. So it is relational, it's bottom up, it's also top down, and the intelligence of the larger thing is not the same thing as the intelligence of the parts. One place where Sarah and I actually differ is that she believes that the Earth as a whole cannot be thought of as alive because its copy number is only 1. Of course, if you have so she's like, well, it'll become alive when we colonize other planets, and then the Earth will be alive because it'll be a reproducer. Fair enough, but my own sense is that any kind of recursive structure like this, has always got to have a top, and the Earth is a pretty good place to put the top because we don't know of other things outside the Earth yet that also do modeling of others and that have some of those kind of properties. Right. But it's still, it's still certainly something that engages in, that is constructed by all of the things modeling inside it and interrelating in all of those ways. Right. So for my money, that's good enough to be alive and intelligent.
So I want to add one thing to this, and then ask you. Life is intrinsically social.
Yes.
Intelligence is intrinsically social. Yes. I think part of what Sapience works is technology is intrinsically social.
Yes.
But there is no single technology. It's always existing in a kind of common relationships with other ones as well.
Yeah, and it's alive as well.
That's what I want to ask you. Yeah. One thing we haven't talked too much about is AI, as much as well. You think AI exists? AI is alive. AI is, or at least AI is life.
Both life and intelligence.
Both life and existence. Yes. I have the persistent existence on the mind. It is both life and intelligence. And when you show us the abiogenesis simulations, you don't think they're not simulations. This is not a simulation of symbiogenesis. This is symbiogenesis.
Yes.
So, could you please unpack for us, why is it? Why do you say AI is alive or life, or what's the difference between them and how these connect? Yeah. Please.
Okay. So first of all, on the simulation and on this question of reality or not reality, there's a big controversy here. Our friend Christoph Koch, has sometimes complained that computers can't be intelligent because they don't exist in the real world. If you have a hydrodynamic simulation on a computer, it's not wet. Look at the silicon; it's not wet. It's a different thing to simulate, fluid dynamics versus to be wet. I get what he means, except that if you have something else in that simulation, that is a part of it, then it is wet, according to the terms of that simulation. Now, I don't know whether there are outer universes that we're a part of, and this is all happening in a simulation as well. I mean, there are people who believe that. I don't think it's an absurd belief, but whether that is the case or not, you have to think about interactions happening within an environment, on a game board, as it were, and whatever is happening on that game board is real on that game board. So, if we want to define life in functional terms, as opposed to in terms that either invoke soul or something supernatural, or that invoke something that is so specific to the way life is built here that it really is completely kind of anthropocentric, then I think you have to do it in functional terms, which is the way Turing talked about it. And when you talk in functional terms, that brings along with it platform independence or multiple realizability, meaning that you're no longer necessarily talking about the nature of the things that are implementing that. You're talking about the thing itself. If, for instance, I come from the future and I show you an object and I tell you, look at this cool thing, and you're like, what the hell is that? I just see a piece of metal with some ports and some carbon nanotubes on the inside, and I say, no, it's an artificial kidney. And if you implant it in a body, then it will, it'll have a 100-year, operating lifetime. That's amazing. Well, its kidneyness is not immanent in the atoms in any way. It could be implemented with all kinds of different technologies. What matters is that if you put it in a body, then in relationship with the other parts of the body, it will do the job of a kidney. That's why it's a kidney. It's a functional statement. It's not a materialist statement.
And it's not a kidney until it's in the body.
And it's not a kidney until it's in the body.
The way in which the technology
and relative to you.
Social relations.
Exactly.
Yeah, okay. One of the also things that Stephanie picked up, and I was also just open up, please jump in with any other questions you want to ask each other before we move to the Q&A. Was this shift between a kind of, one of the ways in which we often think about automation in terms of the replacement dynamic is a kind of biomorphism, where there's a certain sort of something that has occurred in a sort of natural environment, and then there's a kind of lower resolution technical approximation of it, which sort of the assembly line, the rainforest and the assembly line. But you also talked sort of a way in which, perhaps a kind of converse of this, in which humans or other life forms become organized into the machinic automation system, where instead of the morphism, it goes the other direction. It's a kind of technomorphism, by which biology comes to organize itself in relationship to the way the technical system would work, which would seem to me have a lot of implications for what you're saying as well. But could you want to talk, maybe unpack a little bit about that?
Sure, like birds imitating car alarms or something like that.
Birds imitating car alarms, yeah.
I mean, it goes both directions, right? This is not a one-way path where I think it's like nature and then artificialization, and then it's very much this mutual dynamic, and that's why it kind of looks interesting that if we look at the assembly line not as there's many wonderful critiques of the kind of ways that human beings in their fullest extent were reduced through that process to kind of mechanization, but we can also, that actually the learning to implement the physicalized AI was that humans were pretending to be something that they were not. And by performing that, that's how we learn how to actually construct such a thing, is by performing and creating that. On the converse, maybe just to speak to the physicalized AI question, I mean, this is sort of where the dynamic between something like Waymo, which is very protectionist and very concerned about not hitting anything, and Tesla, which is a little bit more renegade, which has a whole distributed network that's actually learning by being out in the environment and feeding that back into the system, that is actually much more like babies bumping into things, or making small mistakes that then update the system and kind of inform that half centralized, half distributed intelligence dynamic that is kind of this dispersion.
Yeah. So landscape is oftentimes, we've talked about this in sort of, is the conservative history of this is a kind of putting green on things, right? A kind of gardening in a way. But what we're talking about here is an emergence of a kind of convergent evolution, by which there is an appearance of forms of machine intelligence, computation, with different levels and abstractions of computation, that is also a landscape scale phenomenon that is in the wild, so to speak, one way or another. But you see where I'm going with this, so please take it away.
And there's a side of this too that, like, as we've been talking about these like kind of questions of de-skilled labor as part of this, and the kidney example, a little bit like the case study I presented today, 3+ minutes. There's a couple sides of it that relate to this, like the idea too that the interpreters sort of said it quickly as being kind of de-skilled or without expertise, but it's precisely that there's an institutional or organizational apparatus that is using them as sensors, in which their particular their particular consciousness is not all that important. They're reflecting on sensation, and only through a disciplined set of yes/no questions are they then told by the apparatus what it was that they actually perceived and how to name it and how to classify it. And I think that's, I mean, it goes back to, I think, some of the comments, you know, Benjamin, that you were saying the other night during the keynote too, that relationship of like, it's not just that we're modeling human intelligence in a fast way, but it's the tools themselves reflect back on what it is to know particular. It's actually shaping,
that's right,
you know, and I feel like it's embedded in some of these early materials as well. And then in terms of like the larger understanding of how processes like this affect our understanding of the natural world, again, just limited to the small case studies that I presented, just to kind of keep it coherent. The folks involved in some of these, their work was stripped of the context, but then published in the kind of main journals of ecology at the time. But what you have then is knowledge of the natural landscape is kind of filtered through this process, and they're only talking about communities of plants or associations of plants that produce scale from an aerial altitude. And suddenly, that point of view, the desire to see things from that altitude at that extent, shapes what the discipline understands about the landscapes that are being described, meaning that there's all sorts of things that get redacted because they're too small to produce scale. And I feel like that sort of recursion of a particular process of kind of disciplined vision filtered through an algorithmic procedure of sense making, connected to technologies of sensing, then go back and through academic channels shape what the sciences actually know about those landscapes is a kind of fascinating, I think, little nugget or case study. It's a template of, I think, a number of the things that have been discussed.
It absolutely is, and it's very connected with what I was going to ask Thomas. I'll sort of make this the last lob, unless anyone else, please join us, and then we'll have a sort of couple questions, and we'll continue the conversation in the lobby, which has to do with that relationship role between, let's say, technology and science and the kinds of things that are. Like what you've talked about is a kind of, I mean, not technological determinism as you meant, but it's a kind of ways in which the possibility of not only the kinds of questions that are asked, but that the basis of epistemology itself is something that's inseparable from the instrumentation through which we think. Whether or not the machine itself is capable of thinking in all the novel and new ways that it now is, this dynamic, the convergence of intelligence, so the sociality of life and the sociality of intelligence and the sociality of technology were never separate from each other. They were always intermingled, right? And so what we may see today as amazing cyborgization and hybridizations is actually, like, always has been. I wonder if you could sort of put this in a little bit of historical context, like the timeline you draw of like these moments of discovery or realization or sort of around this as well, are also ones, like as Blaise described, like they're very much essentially not predetermined, but there was a contingency or a kind of inevitability by which someone would sort of do this. But they were all mediated by a particular moment in the evolution of technology that made the epistemology possible in the first place. I wonder if you could like close us out with some discussion of that.
Yeah, absolutely. That's a great question. Yeah, I mean, the graph is obviously very hard to see, so that's why, you know, Lisa Strausfeld is going to help me and make it into something that can actually be read. But there are moments in there where you can see step changes, and they are all primarily based on scientific discovery, which is based on technical evolution. So, I mean, there's a big one where Curie discovers radium, and suddenly people are like, oh, the sun isn't just collapsing on itself and producing heat via friction. which creates a future on Earth of like a few million years, suddenly people are like, oh, atoms release energy, and the future just... And so that's a good example of like a technology creating a scientific discovery, creating, like this transformation in our sense of ourselves. And a further point I'd want to make is just on the broader historical context is what I see, Blaise's work and Sarah's work, to the degree that they agree, as doing, and what I think is really fundamental, is actually showing us what Darwin told us. And it's because we now have these technological apparatus. So now we can recreate his warm little pond in a computer. I see the kind of truly groundbreaking things that are being done here as, showing us what was so obvious that we just didn't see it before. And one of those is what Darwin did, and he didn't know it himself. But in the sense that Copernicus and Kepler, it was centuries until people started talking about the Copernican revolution. And so there's a similar thing required with Darwin. What did he show us? And so I'm getting to the final point. And that is that he disconfirmed the alternate hypothesis that was still very much live up until that point, that incredibly complicated things could just pop into existence. He showed that we were born from time and from lots of it. And so as an example that I like to use, which I'm sure some of you are familiar with, is literally just a couple of decades before Origin. There's a very famous German biologist, Lorenz Oken, who seriously, genuinely, sincerely thought that the first humans emerged from sea slime. And he worried himself thinking about how this first generation had fed for themselves because there were no parents. And he took this, again, we laugh, but it's, before Darwin, this was a live, viable alternate hypothesis. And so, here we are now, a century and a half later, right? Is it something like that? A century and a half later, and through your work and through Sarah's work, we're really realizing what Darwin told us, is that we were born of time, not slime.
I'm going to steal that one.
We're absolutely ending with that. No, thank you guys so much. So let me just say thanks very much to our panelists here today. We have a little bit of time for Q&A, and so while we're getting the microphones ready and you're sort of thinking about what you may want to ask in relationship discussion, I also just want to extend my sincere thanks once again to the whole Antikythera team, to Haley in particular for helping put all of this together, to our amazing film crew, Morningside, Media Lab, Architect. So many, speaking of scaffolds, so many people, and the designers involved, so many people, hello Andre, wherever you are, who helped design a lot of what you're looking at right here. So my sincere thanks to all of you for helping us together. So with that, let's have a couple thoughts. Yeah, Andrea. Yeah.
Thank you. Of late, anthropocentrism has been getting some bad press, but I would actually like to make the case that Antikythera as a whole is a quite anthropocentric endeavor, and this needs not to be a bad thing. To me, the question of overcoming anthropocentrism, it's something that always struck me as almost a category error, right? It's almost asking as if I could step out of my frame of reference, right? The question not only begs some logical inconsistencies, but also some ethical issues, such as, do I really want to step out of my frame of reference as a human? The answer in my case is no, and I think Tom would also agree with me to some extent. So perhaps I wonder if we are now in need of a better nomenclature for the negative elements of anthropocentrism that in various ways our panelists seem to be critiquing. And to me, perhaps more than thinking of anthropocentrism as a bad thing, one should think of anthropomaximalism as a bad thing. Anthropocentrism can indeed be understood also as a way of promoting human coexistence with the surrounding world, the Umwelt, and so on and so forth. There is a deep tradition of that that starts with, well, the humanism, so it predates Cartesian separations between mind and matter, and so on and so forth. The very idea of planetary sapience, to me, seems to be underpinned by a link between the two, which is anthropos, right? Also as a catalyst of the emergence of a sapiens on a planetary level. And so I was wondering if the panelists could address the fact that perhaps anthropocentrism needs not to be a bad thing, and we maybe in need of a different word to kind of encapsulate the negative elements of anthropocentrism that we seem to be all addressing. And my proposal here would be the idea of anthropomaximalism.
I have my own thoughts on this, but I really would like to hear what everyone else. This is something. This is sort of in your ballpark. But does anyone else want to sort of take a question on this as well?
I can start. I mean, I guess I always thought about anthropocentrism as the problem of like centering the human as the thing around which everything else orbits, right? It's like an orbital problem and a focus problem. And so I think part of the argument of sapience is that humans are one conduit through which intelligence is achieved, and an important one, but also that there's one that will exceed us. And we're not, maybe to Tom's argument, we're not the end of that evolutionary process. So seeing ourselves as part of this, not as the center of it, is maybe the shift. It's not like we want to get rid of anthropos. We're currently very instrumental to it, but we can also imagine a world in which we are not central. And some of the greatest like AI paradoxes speak to this maybe in ways that are also sort of ridiculous because they don't account for the ways in which we actually have played a role in this and might play a role to come if we don't keep fucking it up so badly.
To take a slightly different... Oh, no, please go ahead.
Well, I agree with everything Stephanie just said. And I would say the project here is not one just of decentering ourselves or of trying to not take our own perspective. We'll always have there is no view from nowhere. We'll always have a perspective that comes from, from what we understand and can see in our Umwelt. But it's also important to have some imagination and to not imagine that you are at the top of a great chain of being, or in an org chart, with God at the top and then the people and then the animals and plants and so on. So not taking such an oriented view, but thinking more in terms of networks and also understanding codependency and mutual dependency. I guess I would refer you to Robin Wall Kimmerer and Braiding Sweetgrass and her more recent book, in which she talks about the way a lot of and it's not unique to American indigenous cultures, many cultures that are more conscious of the contingency of their livelihoods on other organisms, take more seriously the idea of putting yourself in the place of even of other species, of instances of other species, other organisms, to try and understand what the shapes of all of those relationships are in order to take better care. So for me, that's kind of at the heart of what it's all about. Recognizing that we're all interdependent and using that awareness to foster something that looks more like a great web of life, as opposed to imagining ourselves to be insulated from it or above it or something.
Let me just we can talk a little bit after this. I suppose where I think you're sort of going with this in a certain way is like. It's true, as Thomas mentioned, like humans are, in essence, the sort of the conduit of a certain form of emergence of planetary intelligence. We are the one who's asking the question, when is now? Which is certainly like why I find a little bit less patience with some forms of sort of post-humanist theory that in a way sort of recognize that mind-body dualism is wrong, that humans are a species, that we're entangled with all these kinds of things as well. But it ends up having a kind of leveling effect by which, there's cognition everywhere, therefore all cognition is the same, right? And it's a kind of becoming vegetal, a kind of will towards a certain kind of mindlessness, a certain mindlessness or a certain kind of way as well. That's clearly not what we're on about. But you had please, I didn't mean to step on what you were saying.
No,
yeah.
Of course. Sorry. Yeah, I just wanted to respond to the question. Yes, I mean, of course, anthropocentrism comes in many forms, and the one that Blaise gestures to, that your point about Gould was well received earlier, but I'm a massive fan, and I would say that above anyone else, he's done more than anyone else to take apart that idea that we are the inevitable end of a great chain of being. So yeah, like we're just purely contingent things. To riff on the patron saint of Antikythera, Stanislav Lem, he said that we are the fluke product of the roulette wheels that are galaxies, which I think sums that up. So we're completely contingent. But to put another point on that is, in a sense, we are currently like the protagonist of planetary history, but there's no reason to think that that's going to continue. And I've been thinking about this recently in terms of like.
But there's also no reason to abdicate this at this point. To sort of say,
yes.
oh, well, it's on. We might as well just let go of the steering wheel.
Yes, but there's also no reason to think that our current idea of what human agency is, and I know you weren't saying this, but is the be-all and end-all, the final saying on agency in the world. For sure, yeah. And so I've been thinking about this recently in terms of the mitochondria. We were talking about this a bit yesterday, but their ancestors used to be bacteria that were freely moving and could reproduce by themselves. Now they immediately occupy most of our cells and provide the energy that makes us do our things.
Right.
And so if we are to become, if we're talking about planetary intelligence, we as individuals are in some sense the mitochondria. Do we sacrifice our autonomy? We probably will have to in order to create that wider and larger coordination. And so on the one hand, I am a human, I don't want that to happen, but then on the other hand, I benefit from all my mitochondria. So centrism, it's like there is no center, yeah.
But there's no, your mitochondria also benefit from being in you. I think,
Exactly.
the thing is, like the trouble that I have with that, and I think it speaks to what you were saying as well, Andrea, is that there is nestedness, of course, mitochondria inside, our eukaryotic cells, which are inside us. But the idea that we are that the we equals something separate from ourselves and our mitochondria, and that we are the boss somehow of them is not right.
Of course.
Right? All these things are composed. And even when we talk about human intelligence, we say we have the steering wheel. Like, what is this we that we're talking about? Even, it's not your brain or my brain or your. It's a collective thing that is already, something that we have ceased to understand, right? To use Lebatut's phrase.
My real point was like this agency that whatever has identified or misidentified as anthropogenic agency, because of course it's a complex of different things that sort of came together with these sort of mutual compulsions and dependencies, or something like this. What I was speaking to is a little bit against a sort of a certain ethos within sort of post-humanism was like the proper response to the recognition of anthropogenic climate change is to try to subtract all possible anthropogenic agency as possible, like essentially to sort of pull back in, and that it's agency itself that is the problem. And this is, to me, like the worst way to deal with a house on fire. That's okay. Perhaps we have another excellent question that will provoke equally interesting debate. Yeah.
Hi, thank you all so much. It's been such a pleasure hearing you all speak today. Yeah. I'm really nervous to ask this question because perhaps it's somewhat of a dumb question. It's a question concerning technology. And I'm curious, technology seems to have its root etymologically in techne, this idea of art, skill, or craft, this logic of art, skill, or craft. And I'm curious, maybe this question is directed at Benjamin, but any of the other panelists. If intelligence is this sort of massively distributed phenomenon that can emerge in bacteria, can emerge in machines, is technology also a phenomenon that can emerge through different species, both alive or not alive? And I'm curious if any of you can sort of expand on this, and how can we define technology in the context of everything that we've all been speaking here today?
It's an excellent question. I'm always happy to sort of re-answer a question that Heidegger asked and got wrong about the question concerning technology. For sure. I mean, I think there's a longer, more technical answer to sort of give about like ways in which we want to sort of define the specificity of technology, of the ways in which a system uses some part extrinsic to itself in order to allopoetically recompose the environment in the service of its capture of energy, information, and matter. But that definition, I think, while true, kind of implies also, again, a little bit of a kind of Vitruvian idea of technology as like there is this self-encapsulated agent that then goes and grabs a tool that goes and does something with, and that this tool has a temporary function. Like, well, this is all the case, but it is the sociality of technology, as we're sort of discussing here, and the ways in which it's always already been part of the process by which biology evolves, by which intelligence evolves, in this way as well. So. In that sense, it's not only there are ways in which it's social with us, but we are social with it. The result of our anatomy, our opposable thumbs are the result of ancestors being, essentially transformed by the technologies with which they come into process as much as it is the other way around. I think part of the question, and one of which we'll try to explore further with the studio that we'll do here at MIT in the summer on this, both the physical and paradigmatic convergence between these ideas of life intelligent technologies, is that these categories may not only are perforating, they may in fact be collapsing to a certain degree, and that many of the kinds of things that we may point at and call that's a technology, like AI, may already have exploded the boundaries of that and what constitutes a technology in the first place. So in that sense, there's sort of the techniques of this. This is actually not, I think, the right way to talk about it. Like, technology may be the wrong word for technology, because it implies essentially a kind of craft and tool that is about making, that in a way extensions us and for Heidegger it alienated us from being, and I think for us quite clearly it's sort of what also discloses our reality to us in one way or another. But I wonder if anyone else has thoughts on this. Yeah.
Very, very briefly, if I may.
Oh, yeah, sure.
Yeah, very briefly, I promise. Yep. That's a fantastic question, it really is. All I would say is that ants invented agriculture and undertaking like 70 million years ago.
Yeah, exactly. Yeah. And agriculture invented ants.
Indeed.
My partner's an economist, which is Blaise's favorite species. And they talk about, like, in economic studies, especially people who study the theory of technology, history of technology, it's really technology is a process, not a thing. And I think part of what we've been talking about is, like, actually technology is an organizational process. And you can follow this through beers and cybernetics and that kind of thing. But it really extends, I think, across a lot of the arguments we've been making today.
I mean, a quick note. Aside from the things that, from ants farming funguses or chimps using sticks to fish ants, and so on. I mean, there are obviously other species and other places on the planet where living things have technologies, which generally is interpreted to mean that the technology is non-living, which already poses some challenges. Is the snail's shell non-living? Right? Things get complicated.
With bones.
But bones, exactly. But what I think has been unique to things that we call human technology that's not the case, more or less, for any other of these technologies of other species on Earth, is that we have theories behind them. We can really think through, how a bunch of things would compose without just trying it all and seeing what works and having whatever works stick. So it's both cultural accumulation and theory. And that is something that AI is poised to do now, which has only been done by humans, which is, I think, a pretty big shift.
And also just add, and theories from them.
Yeah.
And theories from them. It's like this
And
process, the process of the artificialization of intelligence is, in fact, disclosing what intelligence is in ways it wouldn't have been otherwise. But yes, I think we're. Yes.
I wanted to, I'm going to jump right in there. I wanted to come back to this question of imagination that Blaise, you brought up within the context of Benjamin. You definitely identified this, and other people on the panel as well, with life as a form of autocorrect. When it comes to imagining potential futures, alternative futures, future trajectories, is imagination a form of autocorrect? Kind of underlying this question is also, what is the place of imagination in how we define intelligence, how we define life, and also conceptions of the now?
I think it was autocomplete, but autocorrect is good.
Autocorrect implies that there's a correct, but which I don't believe. But
I mean, your definition of intelligence and the capacity to model and predict the future.
Yeah. is imagination.
Not the future,
but a
it's like
future.
like the thing that's going to come next. Like the train will arrive at 7:05, but multiple counterfactual contingent futures that are imaginary until they're not.
The more things you have that you can compose, the more space there is for imagination. Which is why our imaginations become richer as we develop deeper and deeper culture. There's more Lego pieces to play with and to compose in new ways. So I think that the idea that imagination is complete novelty is wrong, in the sense that it always uses things that are there, but it composes them in new ways.
Yeah, if I can speak to that. In terms of imagination and conceptions of now, and I think it riffs on what you just said as well, is that what interests me in trying to map this stuff out is how persistently, again and again, prior generations have been proven to have been incredibly limited in their, from our perspective, in their perceptions of the time scope and the scope of possibilities and the ways in which things can be otherwise. The Victorians were like adamant that there was no way that we'd ever find another form of energy sufficient to sustain civilization outside of coal. That imagination was proven limited, and so what I'm interested in mapping this out is, if everyone before us was proven to have a limited imagination by our lights, I love to think about the ways in which the future will look back on us and be like, their imaginations were limited by our lights, but it's us kind of doing that process and accumulating more Lego bricks that will get us there if all things go well.
Totally. Could we do one more question?
Yeah, indeed. One more Lego brick.
Thanks. I want to come back to something that Benjamin raised, which was the question of the future. I guess in listening to all of this, and in fact, building on the last point about imaginations of the future, I do feel like we are one of the first generations that have seen many very apparent ways in which our future could come to a very rapid end, very quickly. And so I wondered, as we think about intelligence going beyond humanity out to a global scale, who becomes the agent that takes care of our future, and what are our responsibilities as our tiny pieces of that to make sure that that's moving in the right direction and not just beyond us.
Do you think there's, one of the things that I was taken by the sort of the work that you've done on this as well is that not only is there a timeline of a transformation in how much past there is and how much future there is that track each other very closely through time. Like as we discover more past, we imagine more future, but that it's growing. Like the sort of, as you move into the future, the amount of future that is possible to imagine is getting larger. But I think to sort of the point, this reaches a sort of moment where 1953, a definitive date of the Earth is figured out, like we can sort of mark it. It's also the exact same moment when the precarity of whether there will be a future at all kind of emerges. So the idea of the possible future gets bigger at exactly the moment it may go to zero. Is kind of the paradox intelligence at the moment. I would speak the agency question is less about who than what, rather than like a single governor or a single sort of like we get sort of figure that does this, but rather the forms of agency that can be configured in the sort of composed in the trophic cascades that will over the long term give rise to the outcomes that we may never get to see ourselves. But I wonder what you...
Yeah, just briefly, it's something I was in I've been telling everyone, I've been going on about it, but I was in the archives at Harvard the other day and looking through a scientist who is at the forefront of all this stuff in the 50s. And he, as the milieu all were in this time, a physicist, was very into the idea of world government. And again, to riff on the point of how, again, it sounds judgmental, but I really don't mean it this way, how naive prior generations seem to have been. They were so naive about this idea, all we need is just one kind of, authority in charge. And going back even, sorry? Oh, well, yeah, some people do, right? Yeah, and which boggles my mind, but yeah, and going back even further, not to plug, but I've written a piece for Noema that should be coming out soon on this, the very early history of ideas of having a world brain. And they're shocking in terms of like, they almost relish the idea of us as individuals losing our liberty and becoming these like pieces in like, there's a play from the 20s called Brain, and it's about a giant mechanical brain that just encompasses the surface of the Earth. And the author, who is in
Solaris, basically.
Well, yeah, exactly. Yeah, but it's like the intentional production of a Solaris. But the author, who is an ardent socialist, a great writer, he loves the fact that we lose our individuality. And so, I think there's an important question here. Is like in the age of planetary risk, we do need something more than the anarchic chaos that is currently putting us on the brink. What that looks like is a question for the future to come up with. So,
the most optimistic thing that I've seen written about this was in James Lovelock's last book, which he wrote at age 100, Novacene. He wrote, "Gaia will keep the peace," and I don't like it includes AI for him. I certainly don't think that that means we can all just chill out. Right. On the contrary, to the degree that Gaia is intelligent, it's intelligent because we are all intelligent. And the times that we've been saved since 1953 from nuclear annihilation, it's actually all been because of the actions of individual people who decided not to push the button. When in some cases when automated systems told them to do so. But all of those were acts of mutual care. Done by actors who happen to find themselves, at a pivot in history, it's a little scary to think about us, sort of pulling the trigger on that Russian roulette device too often, I do worry about the increasing potentials that we have for all of that. On the other hand, our mutual care, despite all of the dark things that we hear about, is also growing in a lot of ways. So I don't know. I have my good days and bad days about all of this, as you know.
So once again, ending on hope is always a good place to kind of land
Lovelock.
this, and on Lovelock as well. So thank you again, all of you, for coming and joining us over the course of the last 2 days. We will see you at the reception outside, where we continue the conversation. Also, once again, we'll be back. In summer 2025 to do the Antikythera studio here at MIT, and this may be an opportunity to collaborate more directly with some of you, and I certainly hope so. So anyway, thank you so much.